Okay, so this is another example for influence line. So this structure is a frame that is supported by hinges at point A and point B, and then it has an internal hinge at E. So the problem states that determine the influence line for the horizontal and vertical supports. So we have hinges. So at A and B, it has horizontal AX and BX, and then vertical supports AY and BY, and then shear at point E. So these are the supports, so horizontal support and then the vertical supports. So let's solve first the vertical support. So what are the equations for AY and BY, and then what are the corresponding influence line? So here we place a 1 unit load above the frame and then measure that as X distance from the leftmost part of the frame. So this is the free body diagram. So say we have a 1 unit load above, then X distance, that is X distance from the leftmost portion of the frame, and then distance. So first is we solve for AY by summing up moment at point B. So moment at point B, to remove BX, BY, or eliminate BX, BY, and AX, and then we can solve for AY. So distance of the 1 unit load from B, okay, dire man ta mag-moment, ano siya yung distance, which is equal to, so 5, 5, 5, 15 minus X. Okay, so summation of moment at B equal to 0. We have AY, looking at the figure, so we have AY times its perpendicular distance, 5 plus 5, so that is 10, which is equal to the 1 unit load, this 1 unit load, and its distance from point B, which is equal to 15 minus X. And then simplifying the equation, we have the value or the equation for AY, which is equal to 1.5 minus X over 10. And then for BY, so this is BY, if we determine the value of AY, so from the figure, so we know now the value of AY, and then again we have a 1 unit load, and then we can now solve for BY by using the equation summation of forces vertical. So BY is equal to, so if this is the sketch, we have here BY, and then we know now of the value of AY, and then we have the 1 unit load. So by summing up forces vertical, we have BY is equal to 1 minus AY, and then the value of AY is 1.5 minus X over 10, so 1 minus AY, and then simplifying this equation, so we have 1 minus 1.5, which is equal to negative 0.5, and then the negative sign times negative is positive X over 10. So therefore, the equation for BY is X over 10 minus 0.5. So using these two equations for AY and BY, we can now sketch for the influence line for AY and BY. So using the equation of AY nga 1.5 minus X over 10, substitute values of X. So at X equals 0, the value of AY is 1.5. At X equals 5 meters, so 1.5 minus 5 over 10, or 0.5, so 1.0. at x equals 10, so 10 over 10 is 1. 1.5 minus 1 is equal to 0.5. At x equals 15. 1.5 minus 15 over 10, or 1.5, so 0. 1.5 minus 1.5. And then the last is at x equals 20. 1.5 minus 20 over 10, or that is equal to 2. So 1.5 minus 2 is negative 0.5. So this is now the sketch for the influence line with its corresponding values at several points of the beam. And then to sketch the influence line for BY, let's use the equation x over 10 minus 0.5. So substituting values of x, so at x equals 0, negative 0.5, at x equals 5, 0, at x equals 10, 1 minus 0.5, at x equals 15, 1.5 minus 0.5, at x equals 20, 2 minus 0.5, or 1.5. So this is now the influence line for BY. Okay, so we now have the influence line for the vertical supports. So how about the horizontal supports? So for the horizontal support, AX and BX. So what we're gonna do is to place a 1 unit load at the portion before point E and after point E. So this frame is composed of two members. So we assume the 1 unit load to be on top of the first member first, and then analyze or solve for the value of AX, and then place the 1 unit load at this part, or the right member, EFG, and then again solve for AX. So the range of equation for AX is from 0 to 10, so this value of AX, and then so when the 1 unit load is located sa right member, so that equation, the range of the equation is applicable from 10 to 20. Okay, so what are those two equations? So to solve for AX, you have 1 unit load, you have hinge, sa hinge na kay horizontal and vertical reactions. At A, we have AX and AY. So to solve for AX, we need to sum up moment at point E. And then assume counterclockwise positive. So AX will rotate about E counterclockwise. The 1 unit load counterclockwise. AY is clockwise rotation about point E. So we have AX times its perpendicular distance, 3, and then AY will rotate the opposite direction, so supposedly negative. So pag walang tapikas, positive AY times this distance, which is equal to 5, and then minus, so dire this is supposed to be positive, so it transfers sa pikas, may mo siyang negative times its perpendicular distance, 10 minus x. And then simplifying this equation, we will now get this one. So divide these quantities by 3. So we have 5 over 3 times AY. So this is AY value or equation. And then minus 10 minus x over 3, or 10 over 3 plus, this is plus x over 3. Simplify that again, we will get an equation which is 7.5. So 5 times 1.5 divide 3, this value, and then x over 6 is 5 over 10 is 1/2. 2 times 3 equals 6. So the remaining value is negative x over 6 minus 10 over 3 plus x over 3. Simplifying this, and then we will get an ax equation of x minus 5 over 6. So this is applicable for the range of values of x greater than or equal to 0 but less than or equal to 10. And then for the second value of ax, so assuming the 1 unit load is located at the right member, and then analyzing the left member by summing up moment at point E to solve for ax. So we have 3ax is equal to 3ax equals 5ay. 5, so we have ax 5 times ay, and then ax is equal to 7.5 over 3 minus x over 6. So this value divided by 3. And then simplifying it further, we will get an equation for ax of 15 minus x over 6. Again, this is applicable for x greater than or equal to 10 but less than or equal to 20. Substituting these values of ax, we will now have an influence line for ax. And then if we look at the free body diagram of the entire frame, we can say that ax is equal to bx. So the influence line, this influence line, is similar for ax or equal for ax and bx. So they will have the same influence line. And then the last question here is the shear at point E. So shear at this point, or the internal hinge. So to solve for that, in analyzing for the shear, let us remember that we need to get an equation if, or with the assumption that the 1 unit load is before point E, and then another equation when the 1 unit load is after point E. So if the 1 unit load is before point E, and then using the left member of the frame, so this is the left member of the frame, then at a 1 unit load, reactions ax and ay, and then we get the value of shear. So shear when using the left section is downward. So to solve for shear, we can use the equation summation of forces vertical. So we have vertical, this, and then this one. So summation of forces vertical, we have shear E is equal to ay minus 1, where ay is 1.5 minus x over 10 minus 1, or 0.5 minus x over 10. So this is the value for shear at point E. This is when x is greater than or equal to 0, less than or equal to 10. And then assuming that the 1 unit load is after point E, what will be the equation for shear at point E? So nadire si sumpay nga, or the right member, tas nada si 1 unit load. And then again, still using the left member for analysis, we will again assume shear, positive direction for shear when analyzing the left member is downward. So we have shear downward. So wala na si 1 unit load, kaya naman siya diri nga side. So we have summation of forces vertical, shear E is equal to ay, or 1.5 minus x over 10. Substituting values of x, So again, this equation is applicable when x is less than or greater than or equal to 10 but less than or equal to 20. So i-substitute na to ng equation. So kana siya nga sketch sa influence line is diri na siya nga equation. Tapos kani nga sketch sa influence line is kaning ikaduha nga equation. So that's it for this example of sketching the influence line for frame.